challenge this year, and then we'll finish up with my rank. So the key number 9 here is Caddisfly.
Hi, I'm Saurabh, and this is our project Caddisfly. Our project is about making low-cost water testing available to everyone, and especially to those who need it. Okay, so we are a group of artists, designers, and technologists, and we don't have a background in chemistry, electronics, or business. That's just like a disclaimer because we feel that actually helps us have a new approach to this problem, which is, and also, but we also learn these topics as we went along. So the problem which we're trying to address is that of water contaminants, both chemical and organic, in water. This is a really big problem. With, I mean, it's affecting a lot of people. For approximately 66 million people in India are affected by fluoride contamination, which is equal to the population of UK, and the numbers are equally similar for arsenic and bacterial contamination. And these are the three main areas that we're actually trying to work on. And these numbers are just going to get higher because of over-exploitation of water resources and pollution. And these are just examples of what will happen due to sustained exposure to these chemicals. And both these problems, arsenic poisoning and fluorosis, are untreatable. There aren't any known cures for them. Okay, so our solution that we're trying to work with is we're trying to work with the first step of testing, because we feel reliable testing right now is what's lacking, and only once we know the extent of the problem can we actually provide a solution in terms of purification. And we also think it's better to focus on location-specific solutions rather than a one-size-fits-all kind of approach. And also, testing has a they can also they can choose between two water sources. One is bad, like the contaminated versus the other. They have it there, you can choose. There are some existing methods of testing. This is the first. It's called a reagent test. It's a field kit which people can take on the field. It's pretty simple. You just add an indicator to the sample of water, and depending on the amount of contaminant, whether fluoride, we're looking at these examples are mostly for fluoride. And depending on the amount of fluoride, it will change color, and you just have to hold it up against a chart, and then you can figure out how much. But there are a number of problems. I mean, though it's cheap, it's very cheap. The unit is about 200 rupees, and the test costs about 2 rupees. It's a little clunky to use. I mean, you have to mix the exact amount of reagent, and then you have to hold it up against this chart, which in different types of light, it's not very easy, especially if you're a field worker who has to do it like 100 times a day. And even I did this a couple of times, and I got it wrong a few times. And this is the next method. It's called the ion selective electrode method and test, and it's way more accurate. I mean, this is what's used in most government facilities and private facilities, but the cost per unit is really expensive. It's 50,000 and above, and even the per test costs rupees 500 and above. I mean, this is less. In government institutions, it's actually not free, but there's still the issue of actually having to carry the water samples back and forth. It's not an on-field test, and that creates a lot of problems in terms of convenience. Okay, so last year there was a water hackathon held by the WSP and the India Water Portal in October, and our team we entered as Jugaad sensors, and we created a set of low-cost water sensors to help solve this problem. Incidentally, we also won this. So this is how it works. I mean, what we're making is basically a colorimeter. So this is basically how it works. So in theory, there is a dispenser which automatically measures the amount of the reagent and dispenses it into the sample solution. And there are these red, green, and blue LEDs which shine through the sample, and based on the scattering of the light and what they collect, the sensors pick up and transmit the RGB value. So it's a very exact value, which you can. So the human error from having to compare the colors, that's been removed, and also has the human error from possibly having to mix the reagent and the. We haven't actually developed the dispenser yet. We're still trying to figure out the method for that. but we have worked out the rest. So yeah, we made this whole video over 24 hours with basically off-the-shelf electronics, and the circuitry and everything was pretty cheap. It's about 100 rupees at the most for that. We were able to take tests with fluoride and arsenic, like on the silver, and turbidity also, but we hope to include all of these in our kit. Right now, we're aiming to have a cost of about like under 5,000. We are keeping that as kind of high estimate because we don't know how much the packaging and everything is going to come up to, and manufacturing costs and distribution. And the per test cost will be around rupees 2, which is so similar to that of the reagent test. It is basically an update of the reagent test in a way to getting that other kind. So just to kind of give you an overview of the available options. The first is the reagent test, which is cheap, yeah, but it's convenient, and therefore it's not very precise at all. And when it comes to testing, that's really not, it has to be precise. Now the ion selective electrode and the government, they both the same function. The government lab is cheaper, which is it's free. But you don't know who's doing your test, and there aren't really guarantees about that, and so it's maybe not the most precise. And again, they both don't have they're not very convenient in terms of being on-field tests. So as Caddisfly, we are hoping that we're trying to bridge this market between these really low-cost sensors and these comparatively these more expensive sensors, which are way more accurate as well. So I mean, right now, I mean, it's kind of perceived that water testing is a highly specialized field, which is only available to experts and maybe government workers and to the government. But then it's maybe like what we want to do is change that perception. We want to make these products available to the general public. So, and maybe from there, users can be figured out. I mean, just like this code was made in 1925 by one of IBM, and yeah. So this is another added feature. Another feature we want to add, which was a phone interface, which takes the data directly from the tester and uploads it onto a central database, so anyone can access this information as well. So the customers we are targeting, I mean, at the moment we want to sell to existing networks of NGO and health workers and the government, and I mean, eventually we try to expand this market and we try to also sell it as a commodity. So this is where we are right now. We demoed a prototype to one hackathon in October 2012. We are working on a prototype. We hope to have one ready by this November, and post that we'll have to calibrate and test. We are funding ourselves for now, and we have had a verbal commitment from the WSP. And so what we need right now is actually mainly advice from people who have had experience in working with electronics, sales and marketing. And also, if any of you are a customer, if you know Acara, if you can help us identify